Here we're going to have a look at profile diagrams, and this in particular energy profile diagrams. And this is a concept that comes up in GCSE and it comes up in A level. So we're going to look mostly at the GCSE and we're going to extend each graph to the A level standard. And this concept is something that comes with exothermic and endothermic reaction questions. And quite often they'll ask you to label the diagram or draw the diagram or complete the diagram. And it's relatively simple when you know what you're looking for. So we're just going to have a look at those two different types of diagrams, exothermic and endothermic, and how we label them and how they actually apply to the concepts of heat exchange. So this is an exothermic energy profile diagram. And what tends to confuse people here is when you think of an exothermic reaction, you think of it getting hotter. But if you remember the definition of an exothermic reaction, it's where heat energy is released to the surroundings. So the surroundings, which would be the water or the air, which bit you're measuring with the thermometer, normally the water, that is getting hotter. The actual chemicals must therefore be getting colder by the law of conservation of energy. So as the temperature of the surroundings increases, the temperature of the chemicals decreases. And what we're looking at here is the temperature of the chemicals. So just where you start off, you would label your reactants on this line and your products. So whatever reactants they give you, you write down the reactants in the balanced equation on that line, or the word equation if they give you a word equation, and the products go on the second line. Now, as the reaction goes on, which is along here, the energy of the chemicals is going to change. And this is a little bit like building Lego. So if you think of it like that, if I've got, let's say, a car that's built out of Lego and I want to turn it into a house, well, in order to make it into a house, I need to take the bricks apart and then reassemble them as a house. And it's the same with chemicals. You need to take those chemicals apart by breaking the bond, which raises, because you have to put energy in to break bonds, that therefore increases the energy of the reactants. When you remake the bonds to make the products, when you form bonds to make the product, that releases energy, so the energy drops. So you'll always have this loop here. Now, the amount of energy that is released is this amount here. So it's from there to there. And that's the energy that goes out to the surroundings. So that goes out to the surroundings. We call that the enthalpy change at A level, and we represent it with the letter delta, which is that triangle, delta H. So that's the enthalpy change. Now, we also need to be able to label the activation energy. And at GCSE, for some reason, they've started liking it just as a dotted line across here with the label EA. What you should do is it should be from the reactants up to the very highest point of, and that's not quite that accurate there, to the very highest point of that peak. So that should be your activation energy. But just a reminder, at GCSE at the moment, they do seem to want it in the mark schemes as a dotted line just below that peak. All right, and that's how you would go about labeling it. At A level, you must do it like this, okay? EA from the reactant to the top. And that's the energy required to make the reaction actually happen. Let's have a look at an endothermic reaction, because this is pretty much the same. It's the same concept. You're going to label your reactants, whatever they might be. You're going to label your products, whatever they might be, not as an R or a P, the actual chemicals. Now, in this case, you're getting energy from the surroundings. So that delta H value, I should have done this in blue to keep it the same, but I haven't. That delta H value is there from the reactants to the products. And that's the energy that has come in from the surroundings. So that's been gained from the surroundings. And therefore, even though the surroundings got colder, the actual chemicals in the system have got hotter, to use sort of a bit of a term we probably shouldn't use, but they've got more energy now. The activation energy is actually now from the reactants here all the way up to the top. So that is my activation energy. So another common mistake would be to make this blue line from the products, because that's similar to the exothermic. It should be from the reactants. Again, at GCSE, for some reason they have started liking it drawn like a dotted line like that. And that's how you would label and how you would understand a profile diagram.